Okay, so what we're doing is we're going to first let's define. Now I say new Java interface, and oops. Okay, so here's the dessert topping interface, and it's going to have an eat method. Okay, so Java likes that. I'm going to have a second interface called FloraWax. And it's going to have one called wax. And so when I create a concrete class, oops, new this. All right, so here's how I say implements, dessert topping, comma, FloraWax. This is how you implement multiple interfaces. So if I extend, now what isn't written here, even though it is there, since I haven't said this extends anything, but just because I haven't written it doesn't mean that it's not there. So what does this class extend, if anything? Maybe nothing. Objects. Yeah. Yeah. Every class extends object, even so if I don't say anything, if nothing is written, it extends object. And that's all right. So now I get a red squiggly, and it says it's not abstract and does not override abstract method. And it actually just picked one out, but I could either make the class abstract. So now, see, no red squigglies, but if I make it abstract, then I still have to subclass it in order to use it. So if I don't choose that, then I could implement all abstract methods. And this is a really nice feature of IDEs these days. So just say, okay, first of all, it gives the override annotation, which is not required, but is very useful because that tells you, anybody reading this, it tells them, oh, this is a method which is actually kind of prescribed somewhere else. It's the override method, or the override annotation doesn't specify whether you're implementing an interface method or overriding one in a superclass. So that maybe they should have had two different annotations, but they didn't. This is kind of what it is. All right, so let's again, this is just for demonstration purposes. Normally, for components like this, you should never put a print line in. Okay, so just to see what it's called, and then I'm going to say out. All right, so concrete implementation. So again, what I've done is I have implemented this hierarchy. All right, so let's just sort of make sure that it's actually working. All right, so now I can actually, just as before, I can actually define a variable. Okay. However, I can only invoke, in this case, again, this is to understand what the virtual machine does when it encounters a call to a method. In this case, because I have defined topping to be a dessert topping, I can only invoke the methods that are specified in this interface. And that's because of Java's runtime binding that we talked about, late binding. Because at compile time, it has no idea that I could actually invoke the other one on this. So I can eat, but if I try to wax, then it's wax off. Okay, I can't do that. However, what I can do is I can try to cast it to a topping, and again, it allows that because it stands a chance of succeeding. Why does it stand a chance of succeeding? Because, well, it could succeed. It doesn't have to succeed, but in this case it could. So now I can say wax. So now we're eating and we're waxing. And again, just to put a point on this, notice I didn't have a toString. So let's if I print topping, and both, you will see that we will get exactly the same thing. So this actually shows that they're the same object. And if I want to actually test that, I can say topping equals both. Are they the same object? They are indeed the same object. So again, I'm incorporating what we talked about with casting and other types of things before. Okay, so the idea is that this one object, if I only have one of the interface's context, then I can only implement methods of that. But if I now have both in the context, then I can still invoke either method. Okay. So that's multiple